Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill, this is my shop. We're working on an LBSC TICH locomotive, and in this week's episode we're going to make the bypass valve for the water tank that's discussed on page 234. And what's interesting, there's a few older techniques that are talked about in the book, and I want to show a couple of neat things, and I actually have a little Joe Pye type segment in here talking about geometry and the usefulness of the machinery's handbook. So please stay tuned for that. I hope you enjoy it. Here's the completed bypass valve. I'm really pleased with how it came out. The handle, as those of you that have been around the hobby for a while, you'll recognize this is from a PM research kit. I have a bunch of PM research castings and such that I use, and the handle is perfect for this. So I'm really pleased with how this came out. I hope you enjoy this week's episode. Please stay tuned. Give me a thumbs up if you would, if you enjoy it. Ask questions if you have any, and I'll try to be a resource for you. And I just want to say, as a personal moment, our friend Maddie, who's down in Australia and has a great channel, Maddie's Workshop, always been an inspiration to me with the projects that he's done. Glad to see you back in the shop, Maddie. Keep up the good work. We're hoping and praying that everything heals up perfectly for you and that we have many years to enjoy you in the workshop. So thanks everybody, have a great week. Next up on the list for fittings for the boiler for the TICH is the bypass valve, and as you can see, I did like the Tinker John method, made a Xerox of the part and made some step-by-step instructions for me, which was handy because you can do the measurements and so forth and kind of draw it out and think it out. I'm starting with this hex piece of hex brass that'll go into the water tank the 1/8 inch pipe, they call it, little 1/8 inch brass tube, is the actual bypass tube that will shoot water back out into the tank, if you will. So it's two pieces. It's the hex brass and then cylindrical, actually then there's a nut, and of course the valve. So starting with the hex piece, I've already drilled it 3/32 through and then 3/16 of an inch deep by an 1/8 inch, and I just turned the outside diameter to a 1/4 inch. I'm getting ready to make the undercut and thread it. I'll show you came out right on the money. There we go, 1/4 inch. Pretty happy about that. One of the real things I wanted to show you is, I don't know if y'all can tell in the video the difference. I just installed a Harbor Freight lamp, a LED light directly above the lathe, and to me it's so much brighter and nicer. Let me show you real quick. I'll turn it off. Okay, there's the ambient light. I had this fluorescent light that's on, and the one that's shaking that has the little silver housing to it, that's the one that I just turned off. If I turned it on, it would be blinding here. So there we go, turn it on. Very, very nice for using a lathe. It was on sale this past weekend for $18. Pretty happy about that. So anyway, the next step is to make the undercut. I've gotten disciplined about that. I use a cutoff tool, make the undercut, and then file a little lead in on the front for my tailstock threading. Okay, the bottom part of the bypass valve body is pretty straightforward. Piece of 5/16 inch brass, cut off at 1 inch just to make it easy. Center drill, drilled it through 3/32 of an inch. Then I used a large center drill to make the cone shape inside. That will be for the water mating here, the water connection on the bottom. And then I turned this diameter to a 1/4 inch, made my little undercut here, and threaded it to, so you can see, a 1/4 inch by 40. So now it's time to take it out, flip it around. The top part gets threaded the same way. Of course, the difference is it gets drilled and tapped on the inside for the valve screw itself, and then I'll also have to put it in a collet block and drill and tap the side of it to accept the side mount. I'm making the top side of the valve now. I've repeated the process with threading a 1/4 inch part, a quarter by 40 here, and then I drilled it down a little bit shy of the 5/8 inch dimension with a number 30 drill. And then this is, you need a flat bottom for the valve is the point. So I'm using an 1/8 inch drill, 2-fluted end mill, basically what the Brits would call a slot drill. And I went in 5/8 of an inch, just made a flat bottom using this. The last, basically, I had drilled everything except the last like 25 thou. And after drilling it out in successive methods, just like it talks about in the book, I've tapped it 5/32 40 on the inside. That'll be for the screw. It comes out a lot easier if you're using two hands, but I used first the regular starting tap, and then this is the bottoming tap. And obviously I used the tape to make sure I didn't go any deeper than the 5/8 inch overall depth. And here we are back over at the mill using the 5C collet in a square collet block to center drill, and tap. You can hardly see the threaded portion, but 3/16 by 40, a 1/2 inch down, perfectly in the center of the body of the screw. And there's my tap, so the side portion can thread into it, and it'll hold together while I silver solder it. Next step in the bypass valve is making the actual valve itself, and I'm making that out of 303 stainless, the good stuff that I got from McMaster-Carr. I cut off a little 1-inch section that'll be enough to make the part out of. Here's the valve under construction here. I still haven't soldered anything together yet. I do not have a 5C collet for 5/32, but I did order one. I found one on eBay and ordered it, so I'll have one soon. But in the time being, to facilitate this machining of the valve stem, I took a piece of brass, and as you can see, crudely cut it across, and it'll go. It's a 3/8 inch piece of brass. It'll go into a 5C collet. I drilled a center hole 5/32, so I'm sort of making an impromptu 5C. The important thing here, the reason I want a 5C is so I can use the collet block to machine a square at the top, so that I can fit the handle just like the PM Research square portions on the handles go. Now, speaking of that, I got a little Joe Pye moment for you here. If you're trying to figure out, you know you want an 1/8 inch square here, okay, and you're trying to figure out what diameter of a circle would contain an 1/8 inch square. Well, let me show you. It's a right triangle here, and if you're good with geometry, you could just use the Pythagorean theorem, knowing that these sides are 1/8 inch, and you could calculate this dimension here. If you have a Machinery's Handbook book, you can look on the table, the mathematical tables for the distance across corners of squares and hexagons. And the cool thing is that we know this small d dimension is 1/8 of an inch, so we just look in the small d column here for 1/8 inch. There it is, okay, and the dimension E, if you can see that okay, is 0.1768. So that's the diameter of the circle that we will machine for the hand wheel portion, and then we'll use the 5C collet block to machine off the excess to get a perfect 1/8 inch square. Just thought I'd show that. If you don't have a Machinery's Handbook, you definitely need to get one. It doesn't matter from my purposes, obviously. This is an older one. I think I picked it up at a Friends of the Library book sale or somewhere for $9.95, maybe a used bookstore, but it's worth that and so much more. Highly recommend the Machinery's Handbook. Here's the big deal on having the collet block with the 5C collet. Right now I want to make the square, and hopefully you can see that I made a little line before I took it out of the lathe. That it's a 75 thousandths deep area where the square is going to be, and we know from our Joe Pye work on the Machinery's Handbook, actually the diameter of the stock that we've got here is 5/32, so that's 156 thousandths. Obviously that's smaller than the full circle that contains the 1/8 inch square, which would be 76 thou, I think. So long story short, we're going to end up with 4 flats, but we're going to have rounded edges and versus square. But that's okay because we're going to file out the square for the handle anyway. So now I've got this all set up in the mill to take off 15 thou on either side, all 4 sides, and we should have a nice square then. Okay, here's the part of the valve that has the 256 thread portion on it and the square milled. The square came out a little bit less than 1/8 of an inch, so I've got some work to do on my perfect accuracy, but it is a square, and the nice thing is I'll be able to custom fit the hole and file the hole to fit the little handle, so no worries there. So far so good. This should be the final cut, making the 60-degree cone point on the end of the valve. There we go. Turn the lathe off. A rag on this just to show. I haven't filed this or anything. And be careful, if you're tempted to file, don't put score marks there that would impede the sealing capability. But I turned a 219 thousandths portion down to 1/8 of an inch, and then I adjusted my cross slide so that I was able to cut the 60-degree cone point. So I think we're good there. Next will be put the threading die on and thread this portion, this remaining portion, 219 or so thousandths, to the 5/32 by 40. Okay, here's the business end of the stainless steel valve, and as you can see, I've used the tailstock die holder to thread the 5/32 40 for this portion. That's 219 or 220 thousandths long, so I just took a rag. I'll probably polish this up with a little 440 grit while it's still in the lathe, but it seemed to work. Okay, that cleaned up good, so I'll take it out now and let's see how it fits in the body of the valve that we made. Here's a stainless steel valve. Inside the valve body, you can see I've got it cranked down, so it's all looking good. The one thing I wish I would have done is made the number 256 threaded portion smaller and made the square portion a little bit larger. I can always clean that up in the mill or just file it if I want to, but just to show you, here are the PM Research little handles that come with the PM Research globe valves and so forth. So next thing to do is just to drill this out in the center, clean it up, drill it out, and then file it square to fit this, which, as I said, it's strange, it's slightly below an 1/8 inch square. So like I said, I'll work on my geometry a little bit, but I think this is going to work fine. Okay, here's the basically completed bypass valve, at least dry assembled. I don't have haven't silver soldered the fill area in or the pipe there, but there's the completed hand wheel. It came out really nice. I'm pretty excited about that. Very much use of this little extra clamp-on vise I have here, and this is cool. This is a Palmgren, and I got it, I think, from MSC. Somebody. It was not very expensive. But it's a modern version of what I would call like a baby bullet kind of thing. Extremely handy and portable. And I use these little Swiss files, Riffler files, whatever you want to call them. I love these things. You'll see I've inserted a bunch of still shots showing the hand wheel and filing it out. Here's the completed valve, stainless steel valve with the handle and nut and everything on it. Honestly, I wish I would have made this a little bit longer. Another 1/8 of an inch would have made a lot of difference. A little extra clearance there between the handle and the top part of the valve, but there's just barely enough, so I think we're good here. If I have to remake it, it won't be that bad, but I think we're good. So very pleased with how this all came out. It's been a long time since I've done any of this precision work using the Precision Matthews parts, but I really love making valves and it's a lot of fun. So now I'm going to silver solder this all together and pickle it, and I'll bring you back to show you the final thing. Hey folks, here's the completed bypass valve. I'm really pleased at how it came out. It's just a little bit of time in the pickle, the lime juice that I use, and then I use some baking soda, let it soak in some soapy water, scrubbed it off with a bristle brush, wire brush, and it hasn't even been polished on the Dremel yet, so pretty pleased with how that came out. Really excited. This will be the last segment for this week's episode. Please stay tuned as we make progress on the titch and the various boiler fittings.